9 days. Ubisoft spent hundreds of millions of dollars. Built a system connected 24/7 to the internet. Their engineers genuinely believed no one on earth could break it. A group of anonymous hackers, with no office, no budget, no legal protection, destroyed it in 9 days. Today, I'm going to show you exactly how. And trust me, this is not what you think. To understand how games get cracked today, you need to understand the 30-year war that led here. It started in the floppy disk era. Games were simple. They just asked, do you have the serial key? If yes, you're in. That's it. No internet. No verification. Just a string of letters and numbers printed on a piece of paper. Pirates figured this out immediately. They copied those keys, posted them on forums, and millions of people played games for free. So developers got creative. They hid keys inside the game manual. Enter the word from page 14, line. Then came CDRMS. Developers said, the disk has to physically be in the drive for the game to run. Hackers laughed. They wrote tiny patches, 60 lines of code, that told the game the disk was always present. That's where virtual disk drives came from. Software that creates a fake drive. Your computer thinks a disk is inserted. The game believes it. Nobody checks. Every solution created a new puzzle. And hackers kept solving them. Fast forward to today. Welcome to the era of DRM, digital rights management. Think of DRM like this. Old bouncers checked your ID once at the door. DRM is a bouncer who follows you around the club all night, checks your ID every 10 minutes, scans your face, tracks your movements, and calls headquarters if anything looks off. And the current king of DRM? Denuvo, an Austrian company. And before you say I've heard this name before, let me tell you something most people don't realize. Denuvo doesn't just lock the door. It rebuilds the entire house. It wraps itself around the game's code. It injects fake code paths everywhere, dead ends, booby traps, decoy functions, so that even if a hacker gets inside the code, they can't understand what's real and what's a trap. And here's the darkest trick. Denuvo never fully decrypts the game. When you're in a cutscene, only the cutscene code is decrypted. In a gunfight, only that chunk. The rest stays encrypted, in memory, invisible. You can't analyze what you can't see. And if Denuvo even suspects a debugger is running, it corrupts the code on purpose. That's why pirated versions of GTA 4 had the spinning camera glitch. Cars randomly accelerating. That wasn't a bad crack. That was Denuvo sabotage, built into the design. So how do you beat something like this? Let me walk you through the actual process, because this is genuinely fascinating from a reverse engineering standpoint. Step 1, buy the game. Yes, crackers buy the game. They need the clean, untouched executable, the .exe file, directly from Steam or Epic. They're not working with a pirated copy. They need the real thing. Step 2, identify the DRM. Experienced reverse engineers can look at a game's binary structure and immediately tell, this is Denuvo, version 4. It's like a doctor looking at an X-ray. You learn to read the patterns. Step 3, deploy the tools. First tool, x64DBG or OllyDBG, a debugger. This lets you attach to a running process and watch every instruction execute in real time. You see the game's brain firing, line by line. But here's the problem with Denuvo. The moment it detects a debugger attached to the process, it knows. It flags it. Sometimes it shuts down. Sometimes it corrupts. So crackers have to use anti-debugging techniques. Patches that hide the debugger from the game's detection routines. It's a shadow war inside the process. Second tool, IDA Pro. The godfather of reverse engineering. Here's what IDA does. Developers write games in C++, human-readable code. When a game ships, that code gets compiled into machine code. Raw binary. Ones and zeros. Humans aren't supposed to read it. IDA Pro takes that machine code and reconstructs a human-readable structure. It can't recover the original source code, but it builds a map. A flowchart of the entire program. Every function. Every jump. Every condition. And crackers use this map to find the exact moment, the exact line, where the game asks, are you legitimate? And then they remove that question. Against normal DRM, this takes a few hours. Against Denuvo, this is where it gets brutal. The memory dump marathon. Since Denuvo only decrypts small chunks of code at runtime, crackers have to collect those chunks. And the only way to do that is to play the entire game. Every mission. Every cutscene. Every menu. Every loading screen. Every secret area. They trigger every line of code so that it gets decrypted, and they dump it from memory the moment it appears. This process can take weeks. And once they have all the fragments, they stitch them together using IDA Pro, cleaning out fake code paths, removing traps, rebuilding the real structure. One wrong fake line left behind? The game crashes at a specific point. Back to testing. Back to hunting. It's like defusing a bomb where the bomb is 50 gigabytes of code. Here's what most people don't realize about cracker groups. These aren't lone wolves in basements. Groups like Empress, Codex, CPY, Skid Row, they operate like proper software studios. There are programmers, reverse engineers, testers, quality assurance, packages who compress and distribute the final crack. And the only currency that matters to them? Being first. The moment a new Denuvo game launches, a race begins. Every major group mobilizes. The first to crack it gets the reputation, the respect, the legacy. It's not about money. Most of these cracks are distributed for free. It's about proving that no system is unbreakable. And here's the twist nobody expects. Many of these people eventually get hired by the same studios they cracked. Because nobody understands a protection system better than the person who dismantled it. Some of the best anti-cheat engineers in the industry today are former crackers. Now let's talk about the uncomfortable truth. Denuvo gets cracked. Every single time. The question is just how long it takes. Days, weeks, months. And here's what's wild. DM doesn't just inconvenience pirates. It inconveniences legitimate buyers. Every extra authentication check adds load time. Every connection to a verification server is a potential point of failure. Players who paid full price have reported performance drops, stutters, and even losing access to games they owned when servers went offline. There's a reason movements like if buying isn't owning, piracy isn't stealing have exploded online. Games from 10 years ago have become literally unplayable after DIM servers shut down. You paid. You own nothing. I'm not here to tell you to pirate games. I'm here to tell you the full picture. If you grew up in India playing GTA San Andreas off a friend's 4GB flash drive, you know exactly what I'm talking about. Not everyone had 4,000 Indian rupees for a PC game growing up. Piracy introduced millions of people to gaming. Some of those people are now game developers themselves. At the end of the day, if you can afford it, support the developers. Real humans spent years of their lives building these worlds. But the companies making the decisions? That's a different conversation. So here's the summary: serial keys. Cracked. Disk checks. Cracked. Always online DIM. Cracked. Denuvo. Cracked, eventually, always. The only DIM that has never been cracked? Not releasing the game at all. Which, honestly, some companies seem to be trying. If this video made you think differently about how software actually works under the hood, that's reverse engineering. That's cybersecurity. And there's a whole career in this. Drop a comment. Which was the first pirated game you ever played? I'll read every single one. Like this video if you learned something. Subscribe. I break down how real systems work every single week. Next video, how hackers reverse engineer mobile apps. Don't miss it.